In this final lesson, we will explain three statistical measures often used in educational reports. The conceptual meaning will be explained with little technical detail. The goal of this lesson is for you to feel comfortable using reports that contain these terms. We will answer three questions in this lesson. What is a correlation coefficient? What is standard error of measurement? What is a confidence interval? Here are three possible sets of midterm exam grades paired with the same student's final exam grade. Do you see a relationship between the midterm score and the final score? A picture always helps. These are ordered pairs. The graphs are on the next slide. On each graph, the horizontal x-axis is the midterm grade and the vertical y-axis is the final grade. Final A had a perfect positive correlation with the midterm grade. The lowest midterm was the lowest final grade. As the midterm grade increased by 10 points, the final grade increased by 5 points. Final B had the opposite relationship. As the midterm increased by 10 points, the final decreased by 5 points. What about Final C? There seems to be no identifiable pattern here. The correlation coefficient, which is called R, is a measure of the degree to which two variables are associated. It is a measure of straight-line relationships, and it is a measure between -1 and 1 inclusive. It equals +1 when the variables form a perfectly straight line increasing from left to right. It equals -1 when the variables form a perfectly straight line decreasing from left to right. And it equals 0 when the variables form a random scatter with no linear pattern detected. The correlation coefficient R is complicated to calculate by hand. I used an Excel spreadsheet function to calculate the correlation for graph C. Notice that the R of graph C is slightly less than 0, indicating only a very small negative linear relationship. Match each graph of data with its correlation coefficient. Pause the video while you make your choices. Here are the answers. The top graph is mostly random scatter with little relationship. The middle graph shows a strong positive relationship, and the bottom graph shows a fairly strong negative relationship. There are several cautions to observe when using correlation. R shows the strength of a numerical relationship. It does not assign cause. Professional judgment is needed to study causal relationships. For example, there is a strong negative correlation between the number of economically disadvantaged students in a school and the end-of-grade science score average. Does being poor cause a low average? No, but there is probably another variable associated to both, for example, possibly the ability to read science terms, that is the cause. R measures the strength of a linear relationship, and R of 0 does not mean that there is no relationship, only no linear relationship. For example, in North Carolina, the average temperature per month has a pattern as seen here. The correlation between the number of the month and the average temperature is 0. There is not a linear relationship, but there is a relationship. R may be close to 0 when there is a relationship, but it cannot be found because of a restriction on the range of the variables. For example, the correlation between SAT participation and average verbal score is strongly negative when using all 50 states. In 2004, it was -8900. When restricted to 14 states with participation rates between 60 and 77%, North Carolina was at 70% that year, the correlation coefficient was very small, only 1300ths. We will now give a working definition of standard error of measurement that answers the questions, what is it? and what does a teacher need to know about it? We often hear comments from students after a test similar to these. Was I ever lucky? I guessed at most of the test. I knew I'd get a bad grade. I was so sick yesterday, I couldn't think. The teacher asked all the questions that I studied. Oh no, I read this question wrong. So the teacher asked, did the test give me an accurate measure of what my students have learned? Remember, tests are influenced by factors other than the student's actual knowledge. Influential factors are a sleepless night, inadequate nutrition, distractions in the testing environment, exposure to the specific content. The class had just read a particular reading passage that was on the test. Group bias. City students do not understand farm references. Good old-fashioned luck. So we must remember when giving tests that they are always a sample, an estimate of learning, a snapshot in time, influenced by factors other than the student's actual knowledge. We always have error in our test and can therefore only obtain an approximation of the truth, plus or minus some error. Measurement error means that we can underestimate or overestimate a student's true ability or achievement. For large-scale tests like the end-of-grade EOG or the end-of-course EOC test taken by public school students in North Carolina each year, the portion of each student's score that can be attributed to factors other than the student's knowledge can never be known exactly, but it can be estimated. This measurement is called the standard error of measurement, or SEM. There is a statistical formula for this error, and this SEM is reported for each EOG and EOC test. An example is, Patrick's grade 5 reading EOG score was 349. The standard error of measurement for the test is 3. Patrick's true score is estimated to be a score from 346 to 352. If Patrick was tested again, we would expect him to score in this range. The improved estimate of Patrick's true score is a score from 346 to 352. How much confidence do we place in this statement? Confidence intervals give us a statistical basis for making a statement of confidence. They rely on the normal distribution. Recall that for scores that fall in a normal distribution, roughly 68% are within one standard deviation, 95% within two standard deviations, and 99.7% within three standard deviations. Statistical theory has shown that on standardized tests, when students are tested over and over again, 68% of the test scores will lie within one SEM, and 95% of the test scores within two SEMs. Since Patrick's grade 5 reading EOG score was 349 and the SEM was 3, our improved estimate of Patrick's true score was a score from 346 to 352. This is a 68% confidence interval. A 95% confidence interval is 349 minus 2 times 3 to 349 plus 2 times 3, 343 to 355. We can say that if Patrick was tested 100 times, on 95 of the tests, Patrick would score from 343 to 355. When using group averages of test scores, a standard error calculation uses a different formula than that of an individual student. Group means have smaller standard errors, and the larger the group, the smaller the confidence intervals. A 2000 E&R report on measurement error gave formulas to determine the 95% confidence range on the 5th grade reading test for a typical Wake County Public School System school in 1999. The report stated that the range within which a true score probably lies is approximately plus or minus 5 points for an individual, 3 points for a class of 20 students, and 2 points for a school of 100 students. Both this 2000 report and a current 2010 report give much more detail about the standard error of measurement. You will find links to these reports under the Resource tab. This concludes Lesson 6. Can you answer the 3 questions in this lesson? What is a correlation coefficient? What is standard error of measurement? What is a confidence interval?